Hello, Mr. Ryan, right? What's this?
A binary tree.
Binary tree.
Tree.
A tree.
A tree.
Any other?
Graph.
A graph, yes, a graph. This is a binary tree. In 270 days, we talk about to get the maximum average.
That's 274 days.
274 days, subtree. We want to find out, on that day, we talk about the depth search, to find out the maximum average of subtree. Look at this note. This is a subtree, right? The average is 2. This is average 2. And this average is also 2. 2 plus 2 plus 2 divided by 3. How about this? Subtree. So basically you add all the numbers and divide it by the number of the nodes, right? And we want to find out the maximum, right? And we use the depth search. And then we want to find the maximum.
Is 2.
2, right? Let's see. What's the this is 2 obviously. This is 1. Yeah, we have average 2, 1. And what's the average of these? 10 divided by 1, 2, 3, 4, 5. Also 2. Right? Average. This is 7. Okay, we got a winner. What's the average of the entire tree? 5 plus 7 plus 3.
7 plus
15.
10, 15 plus 1, 16. 16
Plus 6, 22. Divided by 1, 2, 3, 4, 5, 6, 7. 22 divided by 7.
Divided by 7.
So, okay, so it's roughly 3 point something, right? So the
3.5.
largest will be 7, okay? So, have you noticed what did I do in order to
Why
put
did you
the...
put 7 when it's not part of that?
That's 7, this is itself is a subtree. So, what in order to calculate the average...
7 because there's 7 nodes.
Yeah. Oh yeah, these 7 nodes, yes, you're right. Okay, so in order to calculate the average, what do we need to know?
You need to know how many nodes are there and every node value.
The sum, how do we calculate the sum?
I think it's like a zigzag thing.
Ah, it's the exact thing. Okay, so what's this mean? Sum divided by the number of nodes. Yeah? And we talk about the depth search. So in order to do this, we need this depth search function to return 2 values. Can you guess what are those? You probably already know, right? Define depth search, root. And this is the maximum average, okay? Come on. So if it's an empty tree, we return 2 values. Can you tell me what are these 2 values? 0, 0. What are these 2 values for the depth search to return? 0, 0. What does it mean?
It means the
Sum?
numbers,
The numbers of what?
n.
The n. The number of nodes, yeah? Okay? 2 values. One for the sum, one for the number of nodes. Left sum and left node equals depth search. Root dot left. Right? And then right s, right n equals depth search. Can you tell me what am I doing here? Root dot right. Okay, so now look, we got the 4 values. The left sum, left node, number of nodes. Right sum, the sum of the right trees and the number of the right trees, right? And now we want to get the maximum of the average. We have this answer equals to maximum of answer. We want to get the maximum of the average, right? So the average will be the sum, left sum plus right sum plus root of value, right? And divided by left node plus right node plus. So this bit, the sum of the left tree is LS. The sum of the right tree is RS. And LS plus RS plus root of value is the sum of this entire tree. Okay? And then the number of nodes. So what's missing here? Can you tell me? The left number of nodes, the number of the nodes in the left tree plus the number of nodes in the right tree plus...
What's the number of nodes in the root?
How many nodes is in the root?
1.
The number of nodes in the root. Come on, what does that mean? What does that even mean?
It's 1.
It's 1, yes. Okay, so look, this recursively we are calculating the answer, yeah. But in order to access this value, we need to put a non-local answer. And then return, we want to return again. We just need to return these 2 values, yeah. So this is 274 days. Okay, coming back to today's question. So we want to find out the number of nodes that is equals to the average of subtree. So for example, the average of this tree is 2, right? So we count 1. 2 equals 2. Right? How many other nodes? The value is equals to the average of that subtree. Can you find any more?
3.
Yeah, of course, the leaf node. I want to counting the number of nodes that equals to the average of the subtree. So look the average of the leaf nodes. The average of this node
2.
2 equals to itself. The average node of 2.
2.
Okay, how about this node?
3.
Okay. Yeah, how about this node? 10 plus divided 1, 2, 3, 4, 5, 2. So 1 is not equal to 2. So how many nodes? 1, 2, 3, 4. We return 4. That's what it means. Okay? This is a depth search. Look at this. This is the recursion depth search algorithm to find the largest, the maximum average of any subtree, right? We want to adapt this approach to count how many nodes that equals to the average of that subtree. Which line here is to calculate the maximum average?
The second last one.
This one, yeah?
Yeah.
Okay, good job. So this one is to get the average. So we want to change it.
M plus Rn plus 1.
This is the average, right?
Mm.
So if this equals to root of value, so if root of value equals this bit, then answer plus equal 1. That's it.
Mm.
Does it make sense, man?
Mm.
Okay, so what have you learned today?
The problem is
There's a subtree,
there's a
And we want
tree
the-
There's a tree, yeah.
and we want to count the nodes, the equal nodes to average.
So we have a tree and we want to calculate how much notes have the subtree of its same value thing
Yeah, okay. And then how do we solve this?
by using depth search.
Okay, so depth search. What's this depth search? What are these two values?
The
Of-
sum and the numbers of nodes.
Why do we need to return a tuple containing one of the sum, one of the number of nodes? Why do we need those?
Because then we can calculate the average.
Where then we can calculate the average. And at this point, we are calculating the average of the subtree of the root, right? And then if we just have to check if the root of value is equals to the average of that subtree, then we increment this answer, right? This is basically the same as 274 days, where we calculate maximum average. Yeah, this bit is the 274 day where we use the recursive depth search. Today, just slightly different. You know, the code is pretty much the same except this one, right? For the recursion depth search, every time we return two values, the sum and the number of nodes in the subtree.
Yeah.
With these two values, we can calculate the average. You can get this the maximum average, or you can calculate, you can count how many nodes the values equals to their average. The time complexity, space complexity, time complexity, On, because we visited each node exactly once. The space complexity, On, right? We're using the recursion, implies that the On calling stack, the maximum number of the recursion depth is n. In the worst case, it would be a linked list. If a binary tree is this way, look at the n nodes, or this way, or it could be this way, right? If there are n nodes, the step will be n, and that's the maximum number of the stack usage. Okay, that's it for today. Bye bye.
Bye.